Very similar problems to the ones that we've done in the past, multiplying rational expressions, but this one happens to have a cube in it, that's all. And then there's some problems that are trinomials that need to be factored, and they're just a little bit harder, but you know, still an introductory algebra student should be able to understand that if they've studied cubes, factoring cubes. This right here is called the difference of squares. So that's going to factor into, it's going to have a 2x in the front of each of the binomials, because 2x times 2x is 4x squared. And then there's going to be a plus 3y and a minus 3y in the back of each of those, because that product is 9y squared, and I have the appropriate minus sign. Remember, the outside and the inside terms disappear. In this denominator, when I go to factor this, my a value, when factoring this as a cube, is the term 2x, because the cubed root of 8 is 2, and the cubed root of x cubed is x. And my b value is 3y. So I'm going to substitute those into the formula for a difference of cubes. So that means that I have to have a minus sign in my binomial, and it's the a value minus my b value. Darn, not the same, oh well. And then it's my a value squared, so 2x times 2x is 4x squared. This sign has to be the opposite of that sign, and it's the product of these two. So 2x times 3y is 6xy. This is always positive right here, and it's the b value squared. So 3y times 3y is 9y squared. And I'll go ahead and put that over here. This is not going to be factorable again. There's not going to be the ability for us to take 4 times 9, 36, and find two numbers whose product is 36 and adds to be 6. That's almost always the case, is that that can't be factored again. So look up at this numerator over here. It's identical to this trinomial. So if you were ending up spending a lot of time trying to factor this, just peek around at the problem and notice that there's a trinomial over here that matches the trinomial over there, and I can think of this as 1 times all of that, and I'm going to be able to cross those off as soon as I'm ready. I want to factor that. So watch for that. Again, the way you would find out, though, is you would use the AC method. I call it the alternative method to factoring a trinomial with a number here other than 1, and there is not going to be two numbers whose product is 36 that adds to be 6. I might use the AC method for this problem, but I'm pretty sure that that's a perfect square trinomial, so I'm just going to factor that in my head, and I know that I need a 2x in the front of each of those binomials because their product is 4x squared. I know I'm going to need a 3y in the back of each of those binomials because their product is that 9y squared, and this inside and this outside, that's a 6xy. That's a 6xy, or double it, giving you that 12xy. And I'm ready now to reduce this problem. So let's go start crossing things off. Let's call that 1. Let's call this and this 1. Oh, son of a gun. And let's call this and this 1. So my answer to this problem is just in the numerator a 1. And in the denominator, I just have that 2x plus 3y, and I'm all set. I've multiplied, but really what I did is factor everything and reduce.